This is the brief on calculating a river's width using trigonometry. So imagine standing on a bridge, right? You're about 3 meters above a river looking down at the opposite banks. Kind of wondering exactly how wide that water actually is. Well, basic trigonometry gives us the exact measurement without us ever having to get our feet wet. First, let's set up our mental diagram. Point P is you on the bridge. Points A and B are the opposite banks, and point D is directly below you on the water. Picture yourself looking down at a 30-degree angle to the left bank and a 45-degree angle to the right. Because those angles differ, point P isn't dead center over the river. It's kind of like sitting on an unbalanced seesaw. And hey, thanks to alternate interior angles, your downward sight lines perfectly match the upward angles from the banks. Second, let's figure out the left side of the river. Distance AD. To do this, we literally just use the tangent of 30 degrees. Since tangent is opposite over adjacent, it's our 3-meter height divided by that unknown line AD. So the left side comes out to exactly 3 times the square root of 3 meters. Finally, we solve the right side, line DB, to get our total width. You know, the tangent of 45 degrees is simply 1, which means our 3-meter height perfectly equals the base, making DB exactly 3 meters. Combine those two distances, and your final river width is 3 times the quantity of 1 plus the square root of 3 meters. By slicing a wide, intimidating river into 2 simple right triangles, we can use tangents to easily conquer real-world measurements.